Hi, folks. Welcome to our first lesson on 8.1. This is the start of our chapter on trigonometry. And in this video, we're going to take a look at right triangle trigonometry. We're going to take a look at some angles, we're going to take a look at some trigonometric functions, and then we're going to take a look at some word problems. Okay? So let's jump right in and get started. All right, so angles. I think we've all seen angles before, but I just want to get a formal definition down here. An angle is the union of two rays with a common endpoint. The endpoint is called the vertex of the angle, and the two rays are the side of the angle. And so that's really fancy language for saying we've got two rays. So a ray is like a half a line, right? There's only an arrow on one side, and it's connected to another ray, all right? The end point where they are, like right here, is called the vertex. And then the angle is inside or in between the two rays, okay? So that's all that means. But what is interesting for us is there are two different ways that we measure the size of an angle. Okay, so we can take this circle right here and we can cut it into 360 slices. And each of these slices would be the same size, okay? And if we did that, if we took this circle, cut it into 360 slices, each slice would have an angle measure of 1 degree, okay? So 1 degree. Now that's going to be super hard for me to draw here, but we'll give it a try. Okay, so if I zoom in here, if I have one ray here, and then I draw a second ray so that the slice between them, oops, the slice between them is super, super small, then this angle would measure 1 degree. Okay. Now, I think we can agree that my diagram's not super accurate, right? In fact, I would want to make that even smaller to fit 360 of those slices in here. But that's the general idea, okay? If we cut this circle into 360 slices, we will get slices that are all 1 degree in size. The other way to measure angles is if we take this circle and we imagine that we cut it into about 6.2-ish. Okay, we're going to be very mathematical here. Okay, 6.2-ish slices. What we get now is not a slice that is measured 1 degree, but it's measured as 1 radian. Okay. And so if I draw a picture here, let's kind of start in the same place we started the first one. So that's where our starting ray is. And if I want to cut this whole space into 6 and a little bit of slices, I really want to have something kind of like this. Okay? And so each slice you can tell is already going to be a little bit bigger. So if I draw one like this, okay, then this will measure 1 radian. And so if we look at these side by side, okay, we've got one side where we're measuring in degrees, the other side where we're measuring in radians. And I think we can tell that degrees are way smaller than radians, okay? So all we need to know is that there are two different ways to measure the angle sizes, but degrees are more like centimeters and radians are more like feet. They're just bigger, okay? Now we can convert between degrees and radians, and it doesn't matter which way we go. Like if we have degrees or if we have radians and we want to get the other one, we begin with this same formula. Okay, so we're going to start with a fraction on the left-hand side where everything is measured in radians. And then on the right-hand side, we're going to start with everything in degrees. Okay. Now it turns out that there are 180 degrees in, let's go back to our diagram for a moment. There's 180 degrees in a half a circle. I think we know that. But maybe what we never knew is that in this same half circle, we actually have 3.14 radians. In other words, we have pi radians, okay? So let's actually add that note to ourselves, that half a circle has pi radians, okay? And that just means it's about 3.14 of these slices. But over here, the same half a circle has 180 degrees. Okay, so it's like we're measuring the same amount, but because the radians are bigger, there's only about 3 of them in a half a circle, whereas degrees, there's like 180 in a half a circle. Okay, so we can use this formula. We take the angle measure in radians, we divide it by pi, and we set that equal to the angle measure in degrees divided by 180. Okay. Now let's look at what happens if we're given degrees. Okay, so if we are given degrees and we want to find the radians, then we're going to plug in our value for degrees into the top of that fraction. Okay. But if we are given radians, all right, someone gives us radians and we're like, we would like to know how many degrees that is, all right, we're going to take the degree measure for radians and we're going to plop it into the other numerator. Okay, so radians on the radian side, degrees on the degree side. All right, well, I think like most things in math, it's done a lot better if we can see an example and kind of see what is that we're talking about, okay? So we've got 3 questions right here that we're going to take a look at. Okay, so example 1, we're going to convert radians to degrees. Example 2, we're going to convert degrees to radians. And example 3, we're also going to convert degrees to radians. Okay, so in other words, if I'm given my radians, that's what I'm going to put in the radians part of my equation. But like example 2 and example 3, if I'm given degrees here, I'm going to want to put those in the degrees part of my formula. Okay? All right, so let's get this started and see what we get. So convert pi over 9 radians to degrees. Here's how we would do that. We would say pi over 9 divided by pi equals my theta, right? It kind of looks like an O with a line through it, over 180 degrees. Okay. Now, what I would do from here is I would go ahead and cross multiply. Okay. And what that's going to do for me is get me no fractions. Okay. So I'm going to get, let's see, theta times pi equals 180 degrees times pi over 9. Okay, so all we did there, we cross multiplied, right? And then what comes next? Well, let's simplify that right-hand side first. And so we might notice here that 180 and 9, I can divide those and I'll get 20 and 1. So really theta pi equals 20 pi. And last step, I'm going to want to get that theta by itself. So I'm going to divide both sides by pi. Divide by pi, and I get theta equals 20 degrees. Okay. So what this means is if someone walked up to you on the street and they were like, hey, I've got this angle, it measures pi over 9, but I don't know how big that is, you can go through this process where you set up your equation, you cross multiply, and you can be like, hey, pi over 9 is actually the same as 20 degrees. Okay? All right, well, let's try doing it the other way. This time we're given our degrees and we want to find the radians. So we're going to set up pi or theta over pi equals 160 over 180. Okay. Now, you don't have to, but my recommendation is always to simplify as much as you can first. So like 160 over 180, I can actually turn into 16 over 18 if I divide everything by 10. But I can actually take that again and divide by 2. So I get 8 on the top and 9 on the bottom. So what I really have is theta over pi equals 8 over 9. And my last step here, honestly, I wanted to get rid of that pi because I want to get this theta all by itself. I'm just going to go ahead and multiply the pi to the other side. So theta equals 8 over 9 pi. And so if someone was like, hey, I have 160 degrees, I need to convert this to radians, you would be like, oh, well, check out this process. It's actually 8 over 9 pi. Okay. Now, some people might write this as 8 pi over 9, and both are okay. All right. All right, let's try a different example. It's going to feel really similar to example 2, but I wanted to do one where there is going to be a negative sign to show us that it's going to be exactly the same idea, except we'll have a negative in there. Okay. All right, so theta over pi equals negative 315 over 180. All right, so we're going to do the same idea where we're going to try and reduce here as much as we can. And I notice that this time I can't reduce by 10, but I can reduce by 5. So on the top, that will give me 63, and on the bottom, that will give me 36. I think I can divide by 3 for both of these. So 63 divided by 3 is 21, and 36 divided by 3 is 12. And oh, I can actually divide by 3 one more time. So 7 and 4. So what we really have is theta over pi equals 7 over 4. And just like last time, oops, don't forget it's a negative though. I forgot that negative the whole time. So negative 7 over 4. Last step here, I took the pi that was on the bottom and I multiplied it over. And so that will give me theta equals negative 7 over 4 pi. Or we can write this as negative 7 pi over 4. And both versions are okay. All right. So let me get all 3 examples on one screen for you. So we've got our 3 examples where we're converting between degrees and radians as kind of a handy skill to know. Okay. But we don't want to do this all of the time. So we want to take a look at this right here. Okay. We're going to learn more about this next time. But this, for those of you who might have already seen something like this before, is called a unit circle. Okay. And on this circle, we found that there are some angles that kind of come up a lot. And so we put them all on the circle so we wouldn't have to worry about, remembering them as much. Okay. So for example, if someone said, quick, tell me what is 120 degrees in radians, you would be like, oh, it's 2 pi over 3. Okay. Or if someone were like, ooh, what is 225 degrees in radians? You would be like, well, obviously it's the same as 5 pi over 4. Okay. So like on an exam, I will definitely provide one of these for you. You don't have to memorize this, but I just want you to know it's a nice collection of all the things. We just have to know like the ones that are the same, right? So like 330 is the same as 11 pi over 6, or like 30 degrees is the same as pi over 6. Okay, but I thought I'd include those in the notes and let you know that they will be included on an exam as well in case you need anything. All right, so we're going to stop this video here, come back for part 2 where we take a look at some trigonometric functions.